All right, so we're doing 8.2, and what this is going to do is we are going to start to show variations of what a sine and cosine curve could look like. And this video shouldn't take that long. I just want to go through some basics right now. But as you can see, so we are very comfortable with seeing y equals cosine of x. We should be comfortable with what it looks like, where it starts up at 1, and then all of the main points that it goes through is pi halves, and then it goes through pi, and then it goes through 3 pi over 2. Things like that where it's 1 and -1 and where it crosses the x-axis. But as you can see, there's a lot of different ways that we can really write a cosine function. These aren't the only 4, but these are just examples. And what we're going to talk about in this section and in the coming sections is how do these affect what happens with the graph and how it changes. It's the same thing that's true about x squared graphs and any other function we've dealt with. There are things that we can do to change what the general form looks like. Maybe it'll be a number that's in front of the variable inside here. So instead of cosine of x, it's cosine of 2x. Maybe it's 2 times the cosine of x. Maybe it's negative cosine of x. And we'll be talking about how each of these are dealt with in each instance. And again, I just wanted to give you these as examples. So what we're going to do is let's look at some more examples of some other equations. So let's talk about the forms. We're only going to get into what happens when there's a number in front of our trig function, and also if there's a number in front of our x. So the deal is that the A is going to always be the amplitude. Now, amplitude is going to be the distance from like the middle of your curve all the way up to the peak. So if you're looking at this graph over to the right, it would be the distance from here all the way to the top. Okay? So A is going to be the amplitude. So no matter what your A is, whether it's positive or negative, that will tell you how high the sine curve or cosine curve is going to go and how low it's going to go. Okay, so the amplitude of this first one would be 5, the amplitude of the second one would be 2, amplitude of the third one, -3, and then 4. The second thing, and we actually need to make a fix on this, keep in mind I didn't make these notes, okay, B is actually equal to, that's what the frequency is called, 2 pi over B is the period. Now, we've talked about the period a little bit. Now, we may not have used these terms, but the period is how long does it take for the function to get back to where it started. So like, for example, if we're starting here on the bottom of this graph right here, the period would be the amount of time it takes to go all the way up and all the way back down again and get back to the exact same spot. Okay, so normally we have a B of 1, so it was like when it was just cosine of x, that was like saying the cosine of 1x. And again, you can see that when we plug that 1 in for B, the period is 2 pi because all the way around one time around the circle is 2 pi, so that's what the period is. Okay, so again, we could figure out what the period is for these by doing, the first one would be 2 pi divided by 4, so that means the period would now be pi halves. Again, what that means is instead of the cosine or sine taking a full 2 pi to do one cycle, now it will be changed to only taking pi halves to do an entire cycle. Next one, 2 pi over 2 would equal pi, so that means the period would now be pi. If we did a half, so 2 pi divided by 0.5, that would equal 4 pi. So that means it would take a full 4 pi for it to take to do a full cycle. And then the other one is pi. So we do 2 pi divided by pi. So that one would be 2. So that one would be one without a pi. So it would take just the value of 2. So in between 0 and 2, it would take a full cycle. Okay, so hopefully that makes sense. So let's look at this graph over here, and we're going to do just a couple of quick things with this. Let's think about what is the amplitude of this graph that is given to us. So again, all we're going to do is count how high it goes. So 1, 2, 3, 4, 5. So the amplitude here is going to be equal to 5. Okay? The frequency, again, the frequency is going to be your B. So sometimes we want to figure out what that's going to be, but we have to figure out what our frequency is, we have to use our period function. So our period here, we can figure it out. So again, if we're going from here to here, okay, from this point to this point, we can count 1, 2, 3, 4. So the period is actually equal to 4. So we can now use that formula, 4 equals 2 pi over b, and we can figure out what the frequency is. So we can solve now. So divide both sides by 2 pi. Actually, let's multiply both sides by b. That would be the easier thing. So multiply both sides by b. So we end up with 4b equals 2 pi. And then we divide both sides by 4. And we get b equals pi over 2. So if we were to write out this equation, we know, again, this isn't the exact equation, but I notice that we're not starting at 0 here. So I'm going to say that this is cosine of pi over 2 x, or we could say, theta or whatever. Because this is what our b is. We solve for our b. We plug that in for the b. Now, the only thing that needs to change here is notice we're starting at -1 instead of +1. So what we can do is that is going to change. Our amplitude doesn't change because it's still going to be 5. But a negative means that our entire graph would flip. So this equation could be written as y equals -5, 5 because that's what the amplitude is, negative because cosine normally starts up here. If it goes down here, it's just being flipped. And then pi over 2 because we solved for it with our period. Okay? So hopefully that makes sense. Let's go to the next slide. Let's do something similar for this one. Okay, same idea. Amplitude goes 1, 2. So we know our A is equal to 2. The period is 1, 2. The period is also 2. So let's solve for our frequency. So 2 equals 2 pi over b. So that means we have 2b equals 2 pi. Divide both sides by 2, so b equals pi. This is a sine curve, but again, if you look at it, the sine curve is going down here. Normally, the sine curve goes up. So it's a negative again. All it's doing is flipping. So that means y would be equal to -2 sine of pi x, or pi theta. Okay? So, and we're going to work more on this in the coming sections, especially 8.3, excuse me. The last two things, all we're doing here is we're solving equations. So we're still solving here, but again, as I've been saying all along, sometimes we can do this without a calculator, and you'll see. Always try and get it to be cosine of something. We need to get rid of the 6 first. So we're going to divide by 6 on both sides. So we are going to be left with the cosine of 2x equals 1/2. Now, the thing is we can still treat this the same way we always did before. We can do this without a calculator, and you'll be expected to do this without a calculator. So what you want to do is, let's assume, let's not worry about this 2 yet. We just want to know, when is the cosine equal to 1/2? This is super important for us to understand how to do. Don't worry about the 2. When is the cosine of an angle equal to 1/2? What is this angle going to equal? So I'm going to rewrite this as the cosine of theta equals 1/2. So I'm going to draw my triangle. Here's theta. So that means that this is 1, this is 2. Hopefully you can figure out by now that that means that this is going to be the square root of 3. So we can figure out that for this to be square root of 3, that would have to be a 60-degree angle, which is the same thing as pi over 3. Okay? So now that we know that theta is equal to pi over 3, here's what we do. So if I know that theta is equal to pi over 3, we write pi over 3, but that's not our answer because we're actually trying to solve for x. So I need 2x. This is the angle. Remember, all this is theta. It's just the angle. We need 2x to actually be equal to pi over 3. So what we're going to do is we're going to divide both sides by 2. And if you divide pi thirds divided by 2, we get x equals pi over 6. Okay, so that's what x is equal to here. It's pi over 6. Why? Because when we double it, we get pi over 3, and that's when cosine is equal to 1/2 is at pi over 3. So that 2 does mess things up a little bit. We first solve for our trig function, and then we set it equal to whatever our angle is supposed to be. Okay, let's try another one, and then we'll be done. Okay, let's solve for this one. So again, first thing is divide by 3 on both sides. So we're left with the sine of 3x equals 2/3. So we can then do sine of theta equals 2/3. So then again, I draw my triangle. Here's my theta. Opposite is 2. Hypotenuse is 3. Okay, so we can do it that way. Or the other way we can do this is we can also use the inverse sign, because again, this is just going to give us a decimal anyway. So we can also do the inverse sign to figure out what that is. So do the inverse sign of 2/3 equals, and you would get 0.730. That would give us our theta. Okay, so now again, this is our angle, is 0.730. That's not, we're not going to get pi over 6 or pi over 3 for this one, so a decimal is fine. But this is our angle, and our angle has to be equal to 3x. So we set it equal to 3x, we divide both sides by 3, and we get x equals 0.243. Okay, so hopefully this one was a lot easier than the previous section. Hopefully we can move forward with this. Don't forget to take your Edmodo quiz if that's been assigned, and I will see you in class.